Okay, here we got the final video for Unit 1. This is the last section, questions taken from the assess itself. And let's go for yellow as usual. Alright then, it says the table shows the probabilities of selecting tickets from a bag. They are yellow, black, green, and they've got numbers on them, 1 to 4. So we have a two-way table there. So for example, the probability of picking up a yellow ticket with a 1 will be 1/20th. Probability of picking a black ticket with a 2 on it will be 3/40ths. There are no black tickets with 3 on it, and there are no green tickets with a 1 on it. So that's how you read it in two directions. So I'm going to take one at random from the bag, and I want the probability that it is green and numbered 2. Right, it's green across there, 2 across there, so I'll grab that one right there. So probability is being green and being number 2, it's 1/8. Better change colour, that's so not clear. So 1/8. Alright. Next one, what's the probability that it is black? Well, it can be that one, nothing there, and that one. It's not about the number on the ticket, it's about the colour of the ticket only. So I need to add, for example, a 10th plus 3/40ths plus these 3/40ths. Now, I know I'm allowed to use a calculator because it's a calculator unit. I'm not going to do that. A 10th is going to be, that's a 40, is going to be 4/40ths. I now add on these 3/40ths and these 3/40ths. I will in fact get 7, 10 out of 40, 10 over 40 as a probability of a quarter, 1/4. Alright, just adding fractions really. Good to revise that. What's the probability of picking a ticket that is not, please note, not green? Well, the best way to work it out is to work out the probability of actually getting a green ticket, then subtracting that from the whole. So let's just do all the greens then. I've got an 1/8 plus 3/16ths plus another 1/8. Well, let's convert them all out to 16ths since that is the lowest common multiple. An 1/8, well, that's 2/16ths. 3/16ths, no change there, and an 1/8 again, 2/16ths. That leaves me with 5 7/16ths. Now that's the probability of actually getting a green. Therefore, the probability of not getting a green must be the remaining to take the remaining number that takes it up to 16. So therefore, 7/16ths from one whole has got to be, let's have a look, 9/16ths. Is that alright? So 9/16ths and 7/16ths make 16/16. That is the whole. So there you go. That's the chance of not getting a green. Now, let's have a look. It's got to be yellow or numbered 4. Well, these are all the yellows, and these are the numbered 4. So I think that this is going to be quite tricky, this. Got to use a calculator. Basically, what's the chance of being yellow? Probability of being yellow and numbered 4. I've got to add 1/20th, 1/16th, 3/40ths, 1/8, 3/40ths again coming down, and 1/8. Now I'm going to grab my machine and I'm going to use a funky button called my ABC button, which can add fractions. 20th, okay, let's do it. So 1/20th plus 1/16th plus 3/40ths plus 1/8 plus 3/40ths again plus 1/8. It's quite a difficult function, this. That gives me, would you believe, 41/80. Oh, so therefore 80 was in fact the lowest common multiple of 8, and of course 16 goes into there 5 times. Yeah, I could have done it without a calculator, but anyway, just to save time. So what's the probability of getting a yellow ticket or has a number 4 in it? It's all these little things here, all these and that one. Alright, and that's it. Next question. Right, a bag contains red, white, blue and green counters. We'll go back to yellow, it really stands out well. Okay, the probability of getting a red is 0.5, okay. Probability of getting a white is 0.1. Probability of red or blue is 0.7. What's the probability of picking the green one? Well, let's just work this out quickly. I can't do it directly. I've got the probability of red or blue is 0.7. Probability of red on its own is going to be 0.5. So I reckon the probability of getting a blue on its own is going to be 0.7 take away the 0.5, which is 0.2. Now I've got everything I need. So I've got my 0.2 for the blue, I've got my 0.5 for the red, my 0.1 for the white. Now I can work out my greens. So the probability of getting a green is 1 take away the red. I've got to take away the white. I've got to take away the blue. And that's all there is to it. So red, white, blue, and the leftovers belong to the green. So that's 1 take away 0.5 plus 1 is 6 plus 2 is 8. Take away 0.8. So probability of getting a green is actually 0.2. Alright? Obviously you can play this back. I did it a bit quickly there. But that's it. Not very difficult. Next one. Yeah, you either love these or hate these. Let's go for red, nice and dangerous. Alright, spinner has 8 equal sections. I can have a 1, 2, 3 or 4 on it. This is a mock-up of an exam question from an AQA. It's not a real exam question. All the numbers appear on the spinner, so none of them are left out. 1 is the most likely score, so the mode is 1. 4 is the least likely score, and 2 or 3 occur as equally likely scores. Well, let's start off with 2 of everything, shall we? So I'm going to assume I've got a 1 and a 1, a 2 and a 2, a 3 and a 3, and a 4 and a 4. Right, let's just take this one at a time. So far everything is totally fair. All numbers will come up equally. 1 is the most likely and 4 is the least likely. Well, to make 1 the most likely, I've got to get rid of one of these 4s and put a 1 there instead. So I'm going to do that right now. So now I've got 3 1s, that's the most likely, and the least likely is 4 now, because there's only one 4 on its own. And look what's happened. I've got 2 2s and 2 3s, and they are equally likely scores. Therefore, after a minute or so, I've done it. So I've got 3 1s, 2 2s, 2 3s, and a single solitary 4. And that, ladies and gents, is the end of the assess of part 9 probability. It's the end of unit 1.